Assalamu alaikum. I am Mohammed Meid Hassan Parvez, ID 11908015. Today I am going to introduce convolutional neural network or CNNs. Basically, they're deep learning approach built for specifically for image processing, learning to detect edges, textures, and shapes directly from pixels. So, a CNN is a deep learning model which are basically developed for grid-like data, especially images. Unlike traditional neural networks, CNNs automatically learn special hierarchies such as edges, textures, parts, and whole objects directly from pixels, which makes them particularly effective for visual imagery analysis. CNNs have transformed the computer visions, driving breakthroughs in image recognitions, object detections, and many other tasks. Traditionally, fully connected networks struggles with images because high resolutions creates too many parameters and it destroys spatial relationship when fluttering the pixels. They also don't naturally handle changes in positions, rotation, or any scales. So convolutional neural networks solve these issues by leveraging special structures, such as small features, scan the image to detect edges, textures, and simple shapes. Whereas deeper layers combine this into high-level features. Uh, Using this approach basically preserve spatial informations. Also, it reduces computational complexity and makes models far more effective for image tasks. In a basic CNN process, an image goes through a sequence of layers. First, convolutional layers apply small filters across the image to detect local patterns, edges such as edges, textures, and simple shapes, which ultimately produce a features maps. Next, we use an activation like ReLU to introduce non-linearity, so the model can learn complex functions. In pooling layers, then we downsample the feature maps to reduce dimensionality and which will ultimately reduce the computation complexity, keeping the most important signals. Finally, fully connected classifier or an output layers uh, turns the extracted features into a product predictions, for example, the probability of each class. In together, these blocks learn hierarchical features from pixels to parts to objects. Feature extraction. In convolutional layer is a core feature extractor in a CNN. It applies small learnable filters called kernels, which slides over the image and compute dot products with local pixels. Each kernel learns to detect specific patterns such as an edge or a corner or a texture. As the filter scans, uh, they produce features maps, which are basically a transform version of the image that highlight where the target pattern appears. Different filters generate different feature maps, which together capture the visual of the model's units. After the convolutional layer, we use the pooling layer to shrink the spatial size of the feature map. This basically cuts the parameters and computations, and it helps prevent overfitting by providing a more abstract representations of the images. Pooling also makes feature detections more robust to small shifts or some kind of distortions. The most common choices is max pooling. In max pooling, in which window we get the largest activations and discard the rest. So the model preserves the strongest signal while compressing the data. CNN are widely used because the same basic architecture works for many vision related problems. So in image classifications, they learn to recognize and categorize objects in photos, uh, in from everyday scenes to medical scans. In face recognitions, they detect and verify faces in images and videos for security and authentication related scenario. And also in medical image analysis, we can use this. Doctor can use this to spot abnormalities in X-rays, MRIs, and other imaginary diagnosis. So also in autonomous vehicles, CNN allows cars to perceive their surroundings and make safer driving decisions. Um, CNN has many advantages. One big advantage is that can learn features automatically for images, so we don't need to design features by hand. Another advantage is parameter sharing, where the same filter is used across the whole image, and ultimately reducing the number of parameters and make the model more efficient. Also, pooling layer helps CNN handles small changes in positions, rotations, or size of objects. CNN also has some challenges also. So training deep CNNs needs high computational powers, usually GPUs. They also records a large amount of level data. Another issue is interpretability issue. Because in CNN it is hard to clearly understand why CNN makes a specific decision. Even though CNNs are very successful, uh, there are still some challenges we discuss, and there are some future improvements we can do. So one challenge is data efficiency because CNN usually needs a lot of level data as we discussed. So researchers are trying to make models work well with less data. Another challenge is robustness and explainability. And the goal is to make CNN more secure and easier to understand, so we can trust their decisions. So in conclusions, CNNs have fundamentally transformed this field of computer vision and continue to be a driving force in artificial intelligence. So there must it helps mastering complex visual data to AI advancement and helping inspiring new research directions and working as a fully feature technologies um, breakthroughs. So that's all from my side about CNNs, and thanks for listening.